Welcome to Maven's Talk series. This session is about evolving SRE engagement models. Programmed by Digitarati, India's first IT finishing school.
You would imagine the context in which this concept of SRE has evolved is really in context of making Google website available 24/7 to business users and defining what availability is and so on and so forth. We'll go through in some discussion later on. But fundamentally, I want to give you perspective that the context in which it was designed versus the context in which today organizations try to adopt SRE is fairly different. So typically, for a site like Google to run and engage versus, an application at an application level in a business context, there are quite a few similarities and quite a few dissimilarities, which I will, touch upon, right, through my conversation. So as you would see, I'm sure many of you would have already heard the story of Turk. The Turk was also known as Mechanical Turk. He was an automation chess player. He manufactured this chess game in late 18th century from, in fact, 1770 until 1854. Right? So for a period of about close to 85 years, it was portrayed as an epitome of automation so this was basically done to impress Empress Maria of Austria. The very interesting aspect of it is it was actually a big deception. In a sense, it was actually a player who was sitting in the machine and who was maneuvering the moves. While this, the machine was also able to play a game, what we call as Knight's Tour. It was always hidden from the user in terms of, what it is doing at the back of it. The Turk was fundamentally a illusion that was able to succeed because of the skilled operator that was really operating it. It eventually won all its games, or rather most of its games, during its appearances in Europe and America for almost, as I said, 85 years. And it defeated champions and public figures like Napoleon Bonaparte and even Benjamin Franklin, for that matter. Now, the reason this story is relevant today is because it was the first time in history that an operating model for so-called artificial intelligence was created. It was well understood that the model needs to be so much efficient that there is no scope of breakdown or downtime during the production hours, or rather the play hours or show hours in this case. And in some sense, this was really epitome of site reliability engineering, the way I really see it. Today, I will give a certain practices for adoption and deploying a successful SRE model. I will also weigh in, perspective from target operating model. As I said, it is how do you really contextualize something which is done to upkeep of a Google website, google.com, to adopting it in context of, the businesses that we operate in. So we'll try to bring in that perspective. I hope to bring in, certain concepts which will help address the design principles which are used and a clearer road for adoption. We will run this through the prism of critical design and adoption steps of SRE. So the steps that you see: assess risk tolerance, define SLOs, reduce toil, plan capacity, release management. These are the topics that I will cover through the prism of operating model, target operating model design. While there are quite a few concepts within SRE which are like your error budgeting, your incident prediction, etc. but I will leave them for the master class. And in this particular conversation today, we will try to touch upon the basic, topics which will help kind of, clear a direction for SRE adoption. I move on to the next slide. Uh, So if you see, any operating model typically has few broader elements to address, which include your people, process, technology, and governance aspects. In addition to these aspects, there are other things like your operations, your strategy, your culture, and so on and so forth. For the purpose of today's discussion, I will try to limit, the exposure to the four core operating model principles. Uh, process SRE function is focused on IT service reliability, and reliability is the word when we say site reliability engineering, right? So reliability is the key word. Significant aspect of SRE is managing demand and supply. So think about reliability for a website. It is about making sure it is available. What does it really lead a user to when you say available? It means whatever is, whenever and whatever is the demand, there is availability of the service, which boils down the entire topic into demand and supply. And that fundamentally leaves down two very critical concepts, in which we will cover through the discussion today. How do you assess demand? What is the real demand, projected demand, versus what is the supply, and how do you really ensure a higher level of supply? And supply is nothing but availability, and between the two is the entire continuum of risk. So how do you really address that? So we will address these topics today. We will very quickly look at the people aspect of it from an enterprise SRE, which exerts a multiplier effect on team's productivity fundamentally. In context of SRE, your decentralized teams are transformed into what we call as an engine of operations, right? So they are the ones who are able to drive without really changing too much of a physical setup for the teams. On the technology side, it provides consistency, it provides repeatability. Um, it The tools of SRE fundamentally provide a platform that can be extended and applied to more and more processes, thereby increasing the speed of delivery, allowing more of innovation, and so on and so forth. Um, and the governance part of it, which is uh, fundamentally ability and intent to objectively assess risk, transparently establish tolerance levels, and subsequently service level objectives, and ensuring adoption across the entire life cycle. So that is extremely important. I I have tried to model this conversation in a fashion such that we discuss the operating model aspects in the ambit of SRE model adoption process. For further discussion today, let's delve into these five areas, which is um, assess risk tolerance, define service level objectives, reduce toil, plan capacity, and manage releases. Uh, while we do that, I want to let you know SRE is concerned with several aspects of a service, which are collectively referred to as production, right? And these aspects include your system architecture, your inter-service dependencies, your instrumentation, matrices, monitoring, emergency response, capacity planning, change management, performance aspects, latency, efficiency, and so on and so forth. So everything that we do from an SRE standpoint needs to be seen from the ambit of many variables, if you will, right? So coming to the spoke about what I say is the 5-step adoption process for SRE, um, and I'll allow the audience to look at the screen and see how well these resonate with your journey of adoption at Stancy. Uh, One of the pivots for adoption will be defining the end objective. in the objective, if the objective is defined in terms of availability, uh, I ask question to oneself, right? What is the kind of availability that we are talking about? How important it is, and what is the risk associated with the lack of availability? And that will fundamentally help define, what is the kind of planning that you need to do with respect to your service level objectives. Uh, while, as dry as it may seem a subject, it is, and a little bit more theory on the topic here. What I have done and what I will do throughout my presentation today, friends, is to give you a perspective from a practitioner's viewpoint as well. And that will include things that we've done, or the best practices that we have seen, as our adoption continuum, and kind of bring in certain more on the ground elements to the discussion as well, right? So in this context, almost always what we have seen is, SREs typically are working on two objectives. One is improve the uptime of any system available, uh, and that can happen by ensuring better engineered products. And second is to reduce the downtime by bringing the systems up quickly and minimizing the unavailable service time. This requires significant amount of automation to ensure faster recovery from a breakdown and free up SREs, from what they call as toil. Subsequently, capacity planning for the desired availability with a view of additional workload, additional feature rollout, additional system interactions, etc. must be planned. Lastly, the release process should not be a piece of art. It should be very repeatable. It should be the science that you're putting into the entire exercise. That's the only way SREs will have bandwidth to create what I call as the golden code. And mind you, even when I call it as a golden code, and if angels were down to write the golden code, they would still need SRE because it is ever evolving. It is not a stationary piece of work. Lastly, there are these again, these five topics that I have listed out here are just the general guidelines. It is more of a change in the organization design, change in culture, a change in skill set, change in performance matrices, how you are measuring a team, how you're measuring people, and so on and so forth. So all these things will put together define a successful SRE model. So I come to the first point, which is assess risk tolerance. In SRE, we manage service reliability largely by managing risk. Reliability is a function of mean time to failure and mean time to repair. Now, the whole objective for SREs is to increase MTTF, mean time to failure, and to reduce MTTR, which is mean time to repair. And there are other things, mean time to service, mean time to average time to repair, and so on and so forth. I'm not getting into the details of it, but fundamentally, uh, think about it, how are you really defining your risk tolerance? Organizations typically need to assess trade-off between availability and cost. That's very important. Higher service availability will need more resources. Again, example being your more server time, your runtime environment, your failovers, your monitoring, and so on and so forth, which will eventually escalate the cost, right? So, however, in many scenarios, I don't want to paint only one side of picture that higher availability is not always desirable. I think in certain scenarios, higher availability is required, and particularly in scenarios which impact organizations' revenues. Any tools, any applications which are client-facing, customer-facing, revenue impacting, obviously uh, demand a very high level of availability, right? It is extremely important to do, back of the envelope calculations when it comes to availability versus cost, and see if you're improving availability, by X percentage points, and we call as nines in terms of SRE, improving availability by 1 9 or 2 9, what is going to be the cost and what is going to be the trade-off to that, right? Also, important aspect is when you do a risk tolerance, when you're assessing a risk tolerance, organizations and particularly product managers need to assess trade-off between innovation, reliability, innovation, reliability, and speed. If the product managers want higher velocity of innovation and high reliability, the speed of execution of the service will have to suffer. Similarly, higher velocity of innovation at a greater speed means lower reliability without a doubt. And the higher level of reliability at faster pace means, a compromise on innovation. So it is extremely critical to define what is the right balance in context of the product or service or the tool that we are really talking about. So if you're talking about a business function, which is more of a customer service kind of a function, not really on the revenue impact side, on the order management side, but on customer service side and query resolution side, uh, is innovation faster or reliability faster, right? Or the speed of execution, speed of change is faster on that. So define, it needs to be. No one has an answer from a SRE team. These are the decisions that need to be taken by the product manager or the function lead. But fundamentally, these go a long way in defining the model, and of course, the kind of cost, etc., that is associated with this model. As a practitioner, what I have seen, some of the points that I would want to highlight here, always analyze system from an end user's perspective, right? Often there is a discrepancy in expectation on service level from the end user's standpoint versus product manager's standpoint, right? And I will take an example a little later in the conversation as well on this one. Uh, But for example, escalation of cost from 1 9s to 2 9s will be exponential. From 2 9s to 3 9s will be further, exponential. So driving the right balance is going to be extremely critical. Secondly, to ensure a seamless failover process to minimize service disruption, uh, one thing which is very typical of almost every organization that I have worked with, right? During a breakdown, while some team members want to implement, a quick solution or a hack, if you will, to, to get the system running quickly. Others, there is always a set of team members who worry that, it will fundamentally become a technical liability in some sense, and a better solution, a faster, instead of faster, a better solution and a permanent fix is required, right? It is, fundamentally boils down to the managers and the technical leaders to play a key role to implement a long-term view and ensure that any technical debt that you are accruing by, doing short and quick fixes, it is being managed well and it is being documented well, and over a period of time the technical debt is paid off, right? And that becomes, I can almost assure you, a challenge because listing out of the technical debt itself, and making sure that it exists in the radar of the senior leadership, and then defining time, budgets, and intent to correct it over a period of time, right? That is extremely important. The last viewpoint from a practitioner standpoint I can share is, for most services, the most straightforward way of representing risk tolerance is in terms of acceptable level of unplanned downtime, right? So while the planned downtime is part of your risk assessment, what would be the unplanned downtime, if you will, right? The moment you're able to assess that, that can help you define, what is going to be your availability, right? Okay, I move to the next point, which is defining service level objectives. Uh, Now, service owners and product managers often insist on SLAs or service level agreement, or rather, on your right hand side, the targets, right? Uh, to define a service level target, it is important to understand what is the service level objective that you are really trying to drive, right? And to define a service level objective, it is important to know what are the service level indicators which you are measuring and how are you measuring them. For higher transparency, these indicators should be standardized and measured automatically. There should be a finite number of indicators, not too few, not too many, or the efficacy is lost, is what I can definitely tell you. While some of these points are out there on your screen, a good SLO is helpful for the development team because it gives you a very finite objective to measure the performance of the team. It gives a very finite objective in terms of how you're really managing the availability of your critical systems. Uh, Again, I have few examples here. If you're even measuring availability, how are you breaking down measure of availability, right? In context of Google, say for example, what they for them availability is function of two very core things. So first thing is how is there a what is the latency, right? Availability is determined 100% for a site like google.com. The only thing that can impact is if some servers are down, then what is the latency that you're really talking about? And second thing is, from a software availability standpoint, what is the availability that you are really defining, at the front end? So this is how they are really defining availability. Now, in context of a particular application, again, availability needs to be understood and well defined in terms of what are the indicators that will help define availability or help define the service level objectives, and then define, how are you going to measure those indicators. Uh, One example that I want to share with you, a very interesting one actually, for one of our, captives based out of Hyderabad, and this is a large customer, a large European customer to be precise. And the challenge that the application that we developed for them was, on the HR side of things, right? And the product manager is very, very keen to have this application because it involves with employee onboarding. It defines the overall experience. And in Europe, typically the experience plays a very large kind of a role in defining system availability and so forth. So the expectation was it is 100% available or 99.99% available, which is allowing users to onboard and finish their activities and tasks at any given point in time and so on and so forth, right? Now this is as a request that we got, we while we designed the system and we developed the entire application for them and so forth, we did a thorough sort of a engagement with the business teams, try to understand what is the current level of engagement with the end customer or the candidates who are joining. Then we realized this application particularly was supposed to be used specifically for temporary hires and college graduates. Now then we analyzed what was the usage of the current system, what was the current peak load versus the usage of the system and so on and so forth. And pretty much we realized that, a 70% availability of the system would be as good as 100% availability for the business user or even the end user for that matter. And now with that information, what we were able to do is from hosting standpoint, from runtime standpoint, from license optimization standpoint, we were able to optimize very significantly. The cost of ownership of this particular tool that we created for them, fundamentally it reduced from, it reduced by 35% is what I can tell you. Right? I don't want to get the numbers here, but fundamentally this is now in production running for last 2.5 years without any issues and without a single user complaint of system unavailable so far. So that is the kind of, I would say, diligence that teams need to do on the ground. While the product manager or the function owners will come and will have a certain view, going detail, doing a deep dive into the system, understanding what it takes and how is it really impacting. Doing that detailed analysis is extremely important to define good SLO. We move to third point, which is to reduce toil. In other words, add automation. Automation provides a platform that can be extended and applied to many more systems than one. And it is important to look at it not just as automation, as a point automation, and there are certain APIs driven automation or certain hard coded automation. It is important to bring in a perspective of automation from a platform's view, right? And it is important because a platform also centralizes the mistakes. So if there is a mistake, I'll talk about certain use cases, etc. as well. But if you really look at any mistake that you've done in one system, you can correct it quickly. Instead of that same fix you have to go ahead and apply for multiple systems off and on. A platform can be extended to perform many tasks, so you can continuously discover more use cases and continuously automate more areas and reduce the bandwidth required to manage them manually, which is an extremely important part of SRE. Further, it is depending on the nature of the task, it can run either continuously or far more frequently, right, than a human can. And it is extremely important, again, taking an example of a American organization where this organization is actually into berries, right? Berry picking and berry implementations, not really a financial organization. But the challenge for them was, to do a QC. And they, of course, want to do 100% QC and the berries moving on through a conveyor belt, and you have to scan it and pick out the right berries and discard the not right ones and so on and so forth. The entire automation system. So earlier it used to happen in batch because it was fairly manual task. They would lay out a certain produce and then do it manually. Now, creating this entire automation system helped them to check individual berry, and that becomes a continuous process now, right? Extremely important in certain business scenarios. So, what are those scenarios where a continuous monitoring, continuous automation versus, periodic runtime or execution is required? That needs to be evaluated for the systems that you are really working on. In infrastructure situations where SRE automation tends to be deployed, humans typically, what we have seen is, don't react as quickly as required. And of course, even if you were to create that kind of a bandwidth, that fundamentally means very significant amount of capacity planning, right? In most common cases, say for example, or failover or traffic switching, they can be very well-defined applications. There are very well-defined workflows which can be very clearly automated. It is important to note, if automation runs regularly and successfully enough, the result is reduced. Result will fundamentally reduce your mean time to repair, for the common faults, and therefore your availability of service engineer or the SREs as we call it will definitely go up. I'll share some practitioner views, certain use cases that I have seen, very quick sort of uh, quick implementation guides, I would say. Um, of course, it is non-exhaustive and it could be very contextual to the applications that you're handling and supporting. But things like your user account creation, your cluster turn up or turn down, your software and hardware installations, your provisioning, server provisioning, and user rights definition, your rollout of new versions, your runtime configuration changes, your dependency changes, etc. All these are some of the very quick use cases that automation platform, I would say, not just automation, but an automation platform can take care of. And once these are done, you would imagine the amount of work coming to an SRE can be very significantly reduced. Right? Having said that, I also want to tell you that automation needs a very careful design and execution. Sometimes automatic procedures can end up making a bad situation worse. Um, so any process that is being automated need to be well defined, well scoped, well understood, and then operate under well defined domains until it is proven and it is rendered live in runtime production environments. And lastly, automation, again, because there are continuous changes which are happening, the DNS team is adding new configuration options, the storage team is changing their package names, and networking teams are changing their, protocols, etc. It is extremely important that there is a regular maintenance and upkeep of automation. As a practitioner, I can tell you the automation or the bots that are running in your environment, they can very quickly become redundant unless there is a very clear ownership which is defined and the entire team is very passionate about managing that. So that becomes extremely critical aspect, as a practitioner, what I can say. So different maturities of automation, etc. You can of course see on your screen. But fundamentally, one thing that I've seen, again as a practitioner, uh, most systems need automation. They may not need it, let me put it this way. Either they need it internally to execute certain functions, they need it to interact with the external environment, or they need to interact with the business user. But there is definitely a scope of automation that can be added, to reduce service time, for any of the SREs. Moving to the fourth point that I have for today, which is intent-based capacity planning. Uh, I have, given certain abstractions out there, which kind of defines, what the uh, intent is, right? And in first case, say for example, it is a clear instruction. There is explicit request. There is no ambiguity. There is no, discussion in terms of what and how needs to be done, right? And as you go down to the fourth point, there is a lot of freedom. The degree of freedom improves very significantly in terms of you're talking about an intent. You want to run a service who at nines of availability. Now, how that availability will happen, etc., can obviously be defined. Now, this is something which is more of a derivative of Google, what I would say is because about the computing power that is required by Google to run commerce, and hence capacity planning set of reliability. SREs proportions, small do not exert such impact on overall capacity planning. However, a broader adoption of SRE function will bring in significant impact on the overall infrastructure utilization, and more adoption across the organization will keep optimizing, the entire function. And therefore, uh, what one would expect over a period of time as a leader, who's really trying to drive SRE model into the organization, would see over a period of time uh, more and more abstractness when it comes to capacity planning starts to permeate into the system. Right? Uh, as a practitioner, a few things that I want to kind of also share with you. As I said earlier, it eventually becomes about demand and supply. So demand forecasting and capacity planning can be viewed as ensuring that there is sufficient capacity and redundancy to serve projected future demand and with required availability. Capacity planning should take both organic growth, which is from the natural product adoption and usage by the customers or the users in many cases, and inorganic growth, which can be, because of new feature launches, feature additions, your um, any business-driven changes, your new integrations, etc., into account. Right? Third thing that I would like to highlight is monitoring of capacity is extremely critical. So while uh, there is a provisioning that is done, etc., but monitoring and keep the rules to monitor simple, so that there is a very clear line of sight in terms of how capacity is being utilized, and what is the risk cover that this capacity is planning is providing. I come to my last point in adoption, which is again, as I say, one of the very critical aspects of it. But uh, if I were to summarize it, I have already summed it up in one sentence. It should be science and not art. SREs need to report on a host of matrices, such as how much time it takes for a code change to be deployed into production, or what is the release velocity, on the entire sort of statistics and reporting on the features in build configuration files and so forth. These engineers define best practices for using tools in order to make sure projects are released using consistent and repeatable methodologies. This needs to cover all elements of release process, uh, right from building, branching, testing, packaging, and deployment, all with a thorough configuration management process. I think one of the very critical things that I have seen again as a practitioner is configuration management is something that, because it eventually comes down to uh, lowest level of atom, which is really executing, if you were to really look at from a body of work to breaking it down to an organ, to a molecule, and to an atom, and then to a proton neutron, it eventually boils down to at that level where the randomness is higher, right? And therefore trying to define it becomes extremely critical. Again, as a practitioner, some of the things that I have seen, most companies deal with the same set of release engineering problems regardless of their size or tools that they use. uh, Versioning of the packages, deployment models, frequency of release, uh, what is the frequency? Should it be a periodic build versus continuous build, and so on and so forth? How do you really define all of this? And when you're really trying to create a SRE model, the processes should be very well defined. Again, going back into the process part and the culture part of your entire target operating model. The processes should be very well defined, repeatable. The tools should be used to accommodate the kind of applications that you are talking about. And fundamentally, it should be as simple as a press of a button, I would say, right? So that is how simplistic uh, release process should be built. Uh, Coming to uh, the few things that I spoke about today, again, going back to the operating model, and I tried to capture these five critical elements through the prism of operating model, I would say. So, what is different now? Now, many elements, I would say, right? You would imagine why are we even talking about it? What is different? Your, sorry. Think about your microservices, your containers, your public and private clouds, your DevOps, your AI MLs, AI ops practices, your digital initiatives going on. There way too many security threats which are coming in your particularly in the BFS business. End user work timings have changed. Your geo spread for the applications has changed. Your dizzying array of devices, you would imagine, people are consuming applications on. Of course, the amount of change which is happening in the code in the feature base itself, and everything amplified with the new business models which are evolving, particularly because of the pandemic, right? Things are changing, and things are changing at extremely fast pace, is what I can tell you. So, given that all this change is happening, today SRE is more critical than it could have been envisioned 20 years ago. It has evolved far past the time limit of site reliability in some sense and become more of a service reliability concept today. It has to be rock solid, resilient, cost effective, open for innovation, and fast. Uh, some of the starter tips I can share on the technology side: select a platform that enables visibility of service and applications across the entire enterprise, or at least a large part of it, which you have a span of control of, as a starting point for prioritizing SRE initiatives. Flexibility, scalability, ease of integration with other systems, extensibility, etc. are some of the things that you would be really looking at today and in the long term. Uh, Having said that, don't just jump in. Evaluate your existing platform for the use before going in for your next investment. The process side, consider starting with modernizing your incident and reporting processes. Practical integration can be relatively painless and return high value for your efforts. Uh, First, incident reporting will lead you to the possible breakdown scenarios, and subsequently preventive interventions uh, to enhance reliability. Extremely critical to know when to expect a breakdown. And the moment your systems allow you to do that, your tools allow you to do that, uh, I can tell you, you've got the 50% of your SRE engagement success matrix covered. Uh, Alongside of it is identify your use cases for your automations and service management very clearly, all the way up to closure. So it should not be a incident which is opened or a incident which is being reported. It should be incident which can happen and any preventive that can be taken and closed and tested. On the people and culture side, enterprise SREs require a paradigm shift uh, in how operations work with the rest of the enterprise world. It is a recalibration from a break fix to optimization and automation. introduce a SRE function with a charity to directly address some of the pain areas, and it is extremely important to make people and teams responsible. Again, going back to what I said, in the when we discussed the defining the objectives, define those objectives clearly, and those objectives should percolate down to your organization design, to people, to teams, because teams are responsible to service those objectives, and that becomes a very critical aspect of making the process successful. Another aspect on people side is highlight the teams which are doing a great job. I mean, people should be uh, rewarded for the right behavior, for the right delivery culture that they create. And yeah, I think that's it. There's nothing particularly special about these concepts except there is surprisingly high number of teams do not take necessary steps to adopt it in the spirit of the adoption of the program, but that is what it is required.